All right, so that was a lot of the background knowledge in video 1. So video 2 has a little bit more problems. So let's take a look at the first problem. So it says determine whether lines are parallel. So the edges of a new sidewalk must be parallel in order to meet accessibility requirements. Concrete is poured between straight strings. How does an inspector know that the edges of the sidewalk are parallel? So in this picture, we have angle 1 and angle 2, and here's our sidewalk, right? So how are we going to know that the new sidewalk is parallel with the road? Well, let's find the measure of angle 1. So that's step 1. Find the measure of angle 1. So we'll know this angle measure, right? Then I'm going to add an angle 3 right over here. Okay? So then we're going to make sure angle 3, the measure of angle 3 equals the measure of angle 1. So make sure that these two angles have the same measure, because then they'd be congruent. Right? So whatever this angle is, measure it. This is on one side of the sidewalk, this is on the other side of the sidewalk. Thus, this would make angle 1 congruent to angle 3. And by the converse to the alternate exterior angles theorem, the sidewalk edges would be parallel. And there you go. Okay. So this is not the only way, right? You could have used other angles, but this is the way that we chose to do here. Alternate exterior angles. All right. Next, let's clear those. There we go. Okay, so we have another theorem here. So this says if two lines are parallel to the same line, then they are parallel to each other, right? I sometimes think of this as the transitive property of parallel lines. Sorry. The transitive property of parallel lines. Okay, so keep this in mind that you can go beyond just two lines being parallel. You can have many lines parallel, and they'll all be parallel together. Next one. Again, just some ideas out there. Okay, here we go. So it says that two lines in the same plane are perpendicular to the same line, then they are parallel to each other. So in this picture here, right, we have line A and line B both perpendicular to C. That is shown by the right angles. So because these right angles are corresponding angles in their position, these corresponding angles are both 90 degrees. They are congruent. And because you have corresponding angles congruent by the converse to the corresponding angles theorem, you'll know that lines A and B are parallel. Okay, so that should sort of make sense. All right, so let's see if we can use these two ideas in a problem. All right, so it says when solving or when building a gate, how does Bailey know that the vertical boards V and W are parallel? So here's your two boards. V goes this way, right? Not like a snake, but that way. W goes this way. The question is, how do we know that they're parallel, right? Well, if we look at this picture here, okay, I have board A, perpendicular to board V. So since V is perpendicular to A, and I also have V perpendicular to W, and V is perpendicular to W. I'm sorry. Yeah, and V is perpendicular to, oh, I'm sorry. And A is perpendicular to W. I apologize. I was trying to look at what I wrote down, right? So this is board A going side to side. This is board W going up and down. And W is perpendicular to A. So because V and W are both perpendicular to A, then we know that V should be parallel to W. And that's by the theorem we just talked about, theorem 2-9, which is on the previous slide. Okay. So again, perpendiculars to the same line are parallel. All right, one more here. So now it says, what should angle 1's measure be to ensure that board B is parallel to board A? So here is board B. Here is board A. So what should angle 1's measure be? So I'm going to use this diagonal board as my transversal, right? So I'm going to call this T for transversal. So we know that this angle here is 35 degrees. So what does angle 1 have to be in order for them to be parallel? Well, these are same side interior angles. They must add up to 180. So the measure of angle 1 plus your 35 degrees must equal 180. We're going to subtract 35 from both sides. This gives us that the measure of angle 1 must be 145 degrees. And that's what the measure of angle 1 must be. And this is by the converse to the same side interior angles postulate. And there we go. All right, so hopefully we'll have some fun doing some problems in class. Thanks for watching, and we'll see you then.